Let's continue to the back side. On the back side, we're going to be starting to graph quadratic equations that are in standard form. And notice the difference is x squared minus 2x minus 1. There's no more an h and a k. We're going to start with the same process. We need to be able to find the vertex. Now, the vertex of the x value, or the x value for the vertex, the equation is negative b over 2a. The value of a is 1, the value of b is negative 2, and the value of c is negative 1. Now, when we think of negative b, we mean the opposite of b. b is negative 2, so the opposite will be positive 2. Now, if you want to write down minus negative 2, it's fine, and that gives you a positive. And the value of a is 1. Remember, there's an invisible 1. The coefficient is 1. 2 over 2. 2 divided by 2 is 1. That is the x value. So the x value is 1. I need to find the y value. So to find the y value, once we find the x value, we can just plug it in to find the y value. So y is equal to x squared minus 2x minus 1. But instead of the x, I'm going to replace it with the 1 so I can find the y value. It'll be 1 squared minus 2 times 1 minus 1. We replaced it with a 1. Now I'm going to simplify. 1 squared is 1 minus 2 minus 1. Y is equal to negative 1 minus 1, so it's negative 2. So the y value is negative 2. Now that we find the vertex, we're going to go 1 and then down 2. That's our vertex for the parabola. I'm going to make my line of symmetry. And I know that because the a value is positive, my parabola will be facing up. So this is my vertex. The equation for the axis of symmetry is crossing the x value at 1, or you can think of this as the equation x is equal to 1. Now, I'm not going to build a table on the left-hand side. Same thing that we did before. I'm going to plug in different values of x. And that'll give me different points. So my equation is x squared minus 2x minus 1. And I'm going to plug in values of x. The values of x that you want, you can plug in any values that you want. But I like to make my life easy. So this is 1, so I'm plugging in 2. Or you can think about this is crossing 1, so I'm going to go to the right, so I said 2. The next point I'm going to plug in is a 3. If I want to plug in another point, I'll plug in a 4. But in this case, I'm just going to plug in a 1 first. Excuse me, a 2. So it'll be 2 squared minus 2 times 2 minus 1. So the value of x is 2. Remember to square first. That'll give you 4 minus 4 minus 1. That gives you 0. Minus 1 is negative 1. That'll be the y value. So my first point is 2, negative 2. It's actually my second point. So 2, negative 2. So to the right 2. 2, negative 1. To the right 2 and down 1. And I'm going to reflect it on the other side. Now let's go and plug in a 3. Now if you want to plug in a 5, it's fine, but then that will give you large numbers. So I usually just go 2, 3, and if I need to plug in another number, it will be a 4. Minus 2, minus 1. So I'm going to plug in a 3. 3 squared is 9, minus 6, minus 1. That gives me 3 minus 1 is positive 2. So my next point is 3, comma 2. So I'm going to go to the right 3, 1, 2, 3, and up 2. And I'm going to reflect it. 2 away from the line of symmetry, 2 over. And that will be the problem. Now we cannot compare our transformation and translation because it's now in vertex form. Example number 4. Last example. If you notice, this is on standard form. So first thing, we have to find a vertex, but the vertex is not given by h and k. So we have to use the formula, negative b over 2a. That's going to give us a vertex. Remember, this is a, this is b, and this is c. b is positive 8, so the opposite of positive 8 is negative 8. 2. a is negative 2. So it gives me negative 8 over negative 4. It's positive 2. That's my x value. Now I need to find the y value. Once I have an x value, I can plug it in to get the y value. We have negative 2x squared plus 8x minus 6. But instead of the x, I'm going to replace it with a 2. Because I want to be able to find out if x is 2, what's the appropriate y value. Y is equal to negative 2x squared plus 8 minus 6. So that'll give me a 2 for the x value. Remember to use your exponents first, order of operations. So 2 squared is 4 times negative 2 is negative 8. This gives me positive 16 minus 6. So y is equal to 8 minus 6, which is equal to positive 2. So if your x value is 2, your y value is also 2 in this case. That'll give me my vertex, so 2, 2. I'm not going to draw the line of symmetry right away. I know it's crossing that vertex. The x value is crossing the x-axis at 2, so this is x is equal to 2. Don't forget to write down your equation for the line of symmetry. And I know that it's facing down because the a value is negative, so I know it's going to be facing down. Something that you want to double check as you go through the process. I'm not going to make my table of values, so if you want, you can just plug in a 3 and a 4. You don't have to use the table of values if you don't want to. Gives me negative 2x squared plus 8x minus 6. I'm not plugging values for x, so I'm going to plug in a, this is a 2, so I'm plugging a 3 and then a 4. So you can just add 1 to the x value. 3, negative 2 squared plus 8 minus 6. I'm plugging in a 3. That gives me 9 times negative 2 is negative 18. That gives me positive 24 minus 6. So that gives me 6 minus 6 is 0. So my next point is 3 comma 0. So I'm going to go to the right 1, 2, 3, and then I'm going to stay there. I'm going to use my line of symmetry to reflect on the other side. Now I'm going to plug in a 4. That'll be negative 2x squared plus 8x minus 6. But instead of the x, I'm going to replace it with a 4. I'm going to square first, so 4 squared is 16 times negative 2 is negative 32 plus 32 minus 6. 0 minus 6 is negative 6. So my next point is 4. 1, 2, 3, 4, and 2, 4, 6. If one point is here, my other point will be reflected on the other side, and that will be my problem. As we mentioned before, this is going to be facing down. Remember not to make a V, it has to be a U, a parabola. So this will conclude our lesson. Please email me if you have any questions. Have a great day, and thank you so much.